super class. Today we're going to learn a little bit about rational expressions. Rational expressions come in handy for uniform motion problems, work problems, and in physics when we like to find resistance values. So it'd be nice if we understood a few things about them, such as this: which numbers cannot be used in place of x for each expression. Alright, so let's look at our expressions. Expression A. X minus 1 over 4x plus 1. Well, in order for this expression to make sense, the denominator cannot be 0. Why is that? Because in math, we cannot divide by 0. Alright, that looks a little better. So since the denominator cannot be 0, we need to take the denominator, 4x plus 1, set it equal to 0, and solve for x. When we do, we will find a list of the value or values which x cannot be. If we subtract 1 from both sides, remember in math we always do the same thing to both sides, we get 4x is minus 1. And then if we divide both sides by 4, just continue this underneath, we get x is equal to minus 1/4. So actually, x cannot be negative 1/4. So the answer to which numbers cannot be used is minus 1/4 cannot be used for x. Alright, now let's look and see what happens when we have a different type of expression. For expression B, which numbers cannot be used in place of x in each expression? So again, the denominator cannot be 0. So we take the denominator, x squared minus 9, and we set that equal to 0. We probably recall from factoring that we can write x squared minus 9 as x minus 3 times x plus 3. This is because x squared minus 9 is the difference of 2 squares, because x is x squared and 9 is 3 squared. So by the zero factor property, we know that x minus 3 is 0, or x plus 3 is 0. So remember that this property tells me that if I have one expression times another expression and the product is 0, either the first expression must be 0, or the second expression must be 0, or hey, I guess they could both be 0. To solve these, we add 3 to both sides here, so x equals 3 would make the denominator 0, and we subtract 3 from both sides here, so x equals minus 3 would make the denominator 0. So the answer to what numbers cannot be used in place of x in expression B is, there are two numbers that answer that, 3 and minus 3. Let's look at a last expression. Notice in expression C, x minus 3 over 2, there are no variables in the denominator. It's true that the denominator cannot be 0, however 2 is a constant number. 2 will never magically change to 0, thus the denominator is not 0. So the answer here is any real number can be used for x. Now we have a special symbol that we used to express any real number, and that is this symbol r with a double line. This means the set of all real numbers. Note that it need not be put in set brackets. The r with the double line indicates that it is a set. So, this allows us to see which numbers cannot be used in place of x in each expression. The simple simple process is we take the denominator, set it equal to 0, solve for x. Whatever numbers we get for x, those are the numbers that cannot be used in place of x, because then you'll end up dividing by 0. Can't divide by 0 in mathematics. Division by 0 is undefined. Good luck.